Good evening, Mid-Cheshire. This is a rough guide to buying your first astronomical telescope. So some of you perhaps haven't got a telescope and are interested in doing so. So hopefully this will be directly of interest. Even if you have got a telescope, I'm sure you often get the question from other people, my youngster is interested, I want to buy a telescope, what should I buy? So you might find some useful hints and tips in here, not necessarily for yourself, but perhaps when talking to other people. So I'm going to be talking a little bit about buying the first telescope, about different telescope types, about different mounts, about pros and cons of different telescopes, and a rough guide to prices. The prices I gleaned a little while ago, but amazingly enough, they're still roughly right. Prices haven't gone up that much in the last year or two. And finally, a few hints and tips of things to watch out for. If you are interested in buying a telescope, before you hand over your cash, just give these things a little bit of thought. So you might want to start with the usual question. I'm sure a lot of you have had this question before. What's the best telescope for my X-year-old niece, nephew, son, daughter, granddaughter, whatever? And you might say, well, start small and work your way up. So start with something that's sort of, reasonable like that. I mean, I'm sure that's the sort of quality most of you have anyway, yes? If anybody have got this sort of... It is a little bit of a joke, except that there's one actual feature of this which is actually quite clever. And that is, this telescope has a binocular viewer. And if you think of youngsters, they find it very difficult to close one eye and look through a single eyepiece. They often grab the eyepiece and try and work out what they're doing. So actually being able to keep both eyes open and use a binocular vision is actually a very sensible idea for kids. So it's a little bit laughable, but credit for actually getting that particular aspect of it right. But other people have said, well, if you have got a real youngster and you want to keep their interest until they're ready for a real telescope, then one option is a small little 76 millimeter Newtonian. And again, it's not to be sniffed at. It's only costing about 50 quid or so, but it's actually got a parabolic mirror. They haven't even cut corners by trying to make a spherical mirror on something so small. So yes, very limited aperture, being only 3-inch, very limited focal length, so there's not much you can do with it other than look at the moon and a few other bits and pieces. But if your youngster is interested and you want to keep them interested, that might be worth having a think about. So if you're in the business of saying, well, I've got some cash and I'm thinking of buying a telescope, what's the best one to buy? Well, there are plenty of guides out there. There are some on the web. Bear in mind that some of them I think are very good, but generally this one, for instance, is very good, but notice sponsored by a particular telescope manufacturer. So they are very well written. They've got huge amounts of information in them. They are very nice, but of course that particular document will only talk about the telescopes from that particular manufacturer. They're not going to advertise their competitors. So just be aware of whether or not you're looking at a guide which is completely independent or a guide that's been written by a particular manufacturer, in which case you're going to get a slightly biased view of the idea of buying telescopes. But these sorts of guides, this one is available as a download on the web, and I can point you to the link if you're interested. I've got a hard copy here if you want to have a quick browse. But it contains some really good, useful information. It starts with the questions. What should I look out for? What's the difference between this and that? Can I still use a telescope in daytime, etc.? Lots of common questions are answered, and then they talk about, well, what do we mean by a telescope that uses lenses, a refracting telescope? What's the difference between that and a reflector? They obviously illustrate everything with one of their own telescopes, but that doesn't matter so much. And they talk about more complex telescopes, not just refractors and reflectors, but what about compound telescopes like Schmidt-Cassegrains, the difference in the various mounts, why you might want different mounts for different telescopes. And they talk about accessories and whether or not you really need the accessories, whether they're optional, different eyepieces, finders, filters, etc. So a very good guide to what you need to know, including if you're not actually ready for a telescope yet. If you are only thinking of binoculars, then they cover that as well in terms of what sort of things should you look out for if you're interested in buying a pair of binoculars. So these guides are great, and there are plenty of them on the internet. I just happened to stumble across this one from Celestron, and I just thought, I have no connections with Celestron, but I just thought it was a particularly good model for how these guides should be put together. Then you might say to yourself, well, I've read these things, and now I've got a basic idea of the different types of telescope. Now what I need to do is look in a catalogue and actually start thinking of, well, what can I afford, etc. And again, there are some very nice catalogues around. But the catch is, this particular catalogue is 75 pages with multiple telescopes per page. In other words, there is a huge amount of information in a catalogue from a particular manufacturer. They sell different types of telescope. They're not just selling you one type of telescope. But just to give you an inkling, I've just taken some of these pages and put them here. So there's our little penguin, or rocket, depending on what you think it is, of a kid's telescope. And after a few pages, you might say, okay, page 1, page 2. Obviously, there's a few different telescopes. They must be different, because some are blue and some are red, so I guess they're different. But yeah, I can sort of get the hang of the fact that there are a few different types, and I can read about them, and there's the specification if I want to know how big the mirror is, and focal lengths and eyepieces and all that. So you keep turning the pages. Oh, there's more telescopes. Okay, that's fine. Yes, there's a few different choices here, and there's some black ones and some white ones, and there's a few that look like Newtonians. Yeah, I can keep a handle on that. But then you keep turning the pages, and you say, oh, right, more Newtonian telescopes. So what's the difference between that one and that one? And that looks exactly the same as that one, apart from there's a bit of white on it. But do I have to read the specification of every telescope to try and figure out why these are all different? And I'm not done yet, because there are still more coming on the next few pages, and now I've got a few, okay, these are on a different mount. But there's even more on the next few pages, and it's getting very confusing as to why on earth might I choose one of these telescopes than the one 10 pages back. So I keep turning the pages, and there's even more, and it goes on and on and on for 75 pages of telescopes. I haven't actually counted how many telescopes, but there clearly are many, many hundreds of models in this particular catalogue. And we're not quite done yet, because there are more telescopes, and eventually we're going to get on to, if you've got a telescope, what type of mount might you have it on, and then eventually we get on to accessories and eyepieces and filters and more eyepieces. So if you've got the stamina to read through a catalogue, after 60 or 70 pages, you will be completely punch-drunk with far too much information. And trying to filter it down, what's the important thing I should be looking for? Even if you've gone through the beginner's guide, it's then very difficult to figure out, well, I can ignore all of those because I don't really need them, and I really ought to be looking down here and looking at those specifications. So it is not surprising that if anybody grabs a catalogue or looks on the internet, which is almost the same thing as grabbing a catalogue, you will find hundreds of possibilities. So it's not surprised that people who've tried to figure out what's the best telescope for me, it's not surprising that a lot of people get very confused. So with apologies for everybody that already knows all this backwards, if anybody's thinking of, I'm perhaps interested in buying a telescope, what sort of thing should I be looking for? Let us just remind ourselves that you could, if you wished, categorize telescopes into perhaps 4 categories. So there are telescopes that use glass to help focus the light, and there are telescopes that use mirrors to help focus the light. And notice these 2 circles overlap in the middle, because some telescopes use glass and mirrors to focus the light. Nobody uses these technical optical language of dioptric telescope and catoptric telescope, but the only reason I'm showing those labels is because these telescopes in the middle, which have elements of lenses and elements of mirrors, those are, strictly speaking, correctly called the combination of dioptric and catoptric, which is catadioptric, which is a real mouthful. But that is the correct way of referring to an instrument that focuses light using a combination of mirrors and lenses. So nobody uses these particular expressions, so let's get rid of those. Everybody calls telescopes that have lenses to do the main work of the focusing. Everybody calls those refractors. And on this side, nobody calls them catoptrics. We all call these things that use principally mirrors, we call those reflectors. But I'm showing this simply because that name, catadioptric, which is a real mouthful, that has sort of lasted, even though people now talk about refractors and reflectors. So these ones in the middle that have elements of both are often simply called cats. simply because nobody can be bothered to spell out or to pronounce catadioptric. So you might be talking about telescopes which, broadly speaking, fall into, are they refractors, are they reflectors, or are they CATs? So at least we've simplified the thousands of telescopes that we're looking at down to 3 types of telescopes, and then we can decide which type might be ideal for us and then start narrowing the decision down. So again, with apologies for everybody that knows all of this, if we're looking at a refracting telescope, we've got a lens at the front end and an eyepiece at the back end. It doesn't matter whether there's a 45-degree diagonal kicking the light sideways. That's just purely for comfort of the observer. It makes no difference to the actual optics. So the objective lens at the front will focus the light down to a point, and then thereafter the eyepiece will allow us to study what's going on. Or if we wish, we'll put a camera at the focus point if we want to use this for imaging. Just about every telescope you'll ever come across does not have a single lens at the front, but has multiple lens elements. By combining glass of different densities, we can keep the so-called chromatic aberration at bay. Chromatic aberration is what happens when light is focused by pieces of glass. Not all colors will come to the same focus. And if you're clever about it, you'll have glass of different density or different refractive indices with different shapes, and you can arrange it so that part of that so-called color fringing, the fact that not all light comes to the same focus, that can be controlled to some extent by having different lens elements. So you might have 2 lens elements in that front objective lens, or sometimes 3. In principle, you can buy telescopes which are doublet lenses or triplet lenses or quadruplet or quintuplet. In general, the more glass you have in there, the more you can control the aberrations, the more you can control any color fringing that might exist. But more glass means more absorption, slightly dimmer image, and perhaps more importantly, more glass means more cash needed to buy that sort of telescope. So it's always a trade-off between what quality of image do you want and how much are you prepared to pay for it. If you don't like the idea that light travels through glass and gets split into its component colors, like in a prism, even if you try and keep it under control, there will be some color fringing in an objective lens, in a refractor. So an alternative is don't use lenses, use mirrors instead. Newton figured this out in the 1600s, so not surprisingly, this is still a popular way of focusing light. It doesn't really matter too much what the shape is. It's actually a parabola rather than anything else. A parabola just happens to be the right shape for focusing light from infinity to a nice focus. But of course, we wouldn't want to put an eyepiece here, because if we put an eyepiece here, then our head would block the incoming light. So we need to do something with that focus. Unlike a lens where the focus is on the other side, here the focus is on the same side as the incoming light. So Newton said, why not put a flat mirror there and send the light out sideways through a hole in the tube? And that is the classic Newtonian that perhaps a lot of us know and love. Mirror at the bottom and a little eyepiece at the top, looking at that flat mirror where the light is coming out the side. From this point on, I'm not going to actually show the eyepiece itself. I'm just interested in how the main mirror, or combination of mirrors and lenses, focus the light to the point where we can either place a camera or we can place an eyepiece. I won't actually be showing the eyepiece from this point on. So that's one way of using a reflecting telescope, is to have a flat mirror and send it out the side. But an alternative, called a Cassegrain design, the light again comes to a focus. We don't want to put an eyepiece here. Alternatively to sending it out the side, we can do something different. We can intercept the light before it comes to a focus with a little curved mirror, in which case the light goes back down the tube through a hole in the main mirror there. This is a so-called Cassegrain design. It's used by a number of different telescopes. One advantage of this particular way of focusing light, perhaps you noticed that the light has effectively been folded in a sense, because originally the light was coming right to left, then it was going left to right, now it's going right to left again. So we folded what is a relatively long focal length, the distance from the mirror to where the focus is. We folded that into a relatively compact tube, a physically small telescope. In the case of the Hubble Space Telescope, for instance, the distance between the mirrors is only about 5 meters. Remember, the Hubble Space Telescope, that's not the entire telescope. The telescope only occupies about a third of this length. There's a whole load of instruments at the back. and there's a big sun shield at the front. So the optics are in the middle third. The optics are about 5 meters from end to end. But the focal length of the Hubble is about 57 meters. A huge focal length has been folded into a relatively compact cylinder, and that's the same of any Cassegrain type design. There's a way of making Cassegrain telescopes cheaper, which is something we know and love, and that is, rather than having an expensive mirror here made into the shape of a parabola, it is physically easier to make a shape of a mirror which is effectively just a section through a sphere, a spherical mirror, rather than a parabolic mirror. It's not necessarily that difficult to make parabola, but machines can make spherical mirrors dead easy and hence dead cheap. So one alternative is to say, well, if we were to put a spherical mirror here, then the telescope would be a lot cheaper, but it wouldn't focus quite as well. We would have a little bit of aberration. We wouldn't get pin-sharp stars. And somebody figured out, not surprisingly from the name, a chap named Schmidt figured out that if you take the Cassegrain design, replace the mirror with a cheap mirror, it won't be perfect, but you can correct for that by including an extra piece of glass at the front of the telescope, a so-called corrector plate. That might sound a bit odd. Why make that cheaper if you then have to make it more awkward by adding a piece of correcting glass? Well, it turns out that that isn't particularly expensive to make either. It's relatively thin. It looks like it's 2 parallel sides. It looks like a piece of double glazing, but no, it's actually slightly curved on one side and flat on the other, and it can be made reasonably cheap. So what we end up with is a Cassegrain type design, but with a cheaper mirror and a corrector plate on the front. And that's why telescopes like this appear to have a flat piece of glass at the front. It's flat on one side, curved on the other, and you can't tell from this picture, but the mirror at the bottom is the cheaper type that is easy to mass produce. And so that meant these telescopes could be made in large quantities, and so some decades ago these were made in vast numbers, and ever since have been very popular with amateur astronomers. There's an alternative way of doing the same thing, putting a curved mirror here to fold the light backwards. But again, somebody, in this case a guy called Maksutov, figured out that there's a different way of doing it. It's an optically different way. Instead of putting a flat corrector plate at the front, you put a curved piece of glass. And instead of having a separate mirror, you simply paint a spot, a reflective spot, on the back side of that particular piece of glass. So you don't need a separate mirror stuck on the back of the corrector plate. And that is called a Maksutov design, or sometimes more correctly a Maksutov Cassegrain design, because it's again a Cassegrain with this particular way of correcting for the fact that we're using a spherical mirror. It's characteristic in the sense that whenever you see a telescope in which the front element is concave and appears to be going inwards, that means that you're looking at a Maksutov design. If it's flat, you're looking at a Schmidt-Cassegrain. If it's curving outwards, you're probably looking at a refracting. So you can effectively tell the type of telescope at a glance just by looking at what that front element looks like. Is it bowing outwards, is it bowing inwards, or does it look optically flat? So that's a Maksutov design. Again, it has the advantage of a relatively long focal length in a relatively small tube. For instance, you can now buy Maksutov telescopes which are barely longer than about that sort of distance, and yet the focal length is about 1.5 meters, a very compact way of getting a long focal length telescope. So we've got these various telescope types: refractors, reflectors, Maksutovs, and Schmidt-Cassegrains. But we've got to put them on some sort of a mount, and the mount can be, in some cases, even more expensive than the telescope, depending on what sort of system you're going for. One of the cheapest ways of mounting a telescope is to put it in a very simple, virtually homemade device which allows the whole system to rotate and move up and down, a so-called altaz. We need to be able to move in altitude, up and down, and we need ideally to be able to move left and right in azimuth. And altaz mounts can look anything from a homemade box like that to small devices like this. Some altaz mounts look quite different simply because the telescope is mounted on an arm. That just is a way of manufacturing that is a little bit cheaper than other ways of doing it. For instance, you could put an altaz system and you could have the telescope mounted in a fork. that allows it to move up and down and allows the fork to go backwards and forwards. So again, what's the advantage of one arm rather than two arms of a fork? It's just a question of the manufacturing process, and some manufacturers prefer one, some manufacturers prefer the other. Generally speaking, the more you pay for the mount, the more sturdy, the more precise it is. And in some cases, it might have a computer built in that allows you to point automatically to different things in the sky. But you should always look for a telescope on as sturdy as mount as possible. Regardless of what functionality it has, it must be steady enough to hold the telescope to point at the bit of sky that you're interested in. So if Altaz will do the job, why on earth would you choose a telescope which has got axes of movement at such jaunty angles? That looks like it's just making life difficult for no good reason. But if you think about the Earth and the way the Earth moves, it spins on its axis points to the North Pole, the North Celestial Pole, and that means that if you've got a telescope somewhere, let's say in the mid-latitude, somewhere around the UK latitude, if you arrange it so that one of the axes of your telescope is lined up in the same direction as the Earth's axis, that means as the Earth turns, you only need to turn the telescope on one of the two possible axes in order to counter the fact that the Earth is rotating. So you only need to either move or, if you wish, drive with a motor one of the two axes. So it simplifies the whole process of moving the telescope to a particular point in the sky. Some people don't like them. Some people prefer just give me left, right, up, down. I don't care about which way the star is drifting or the fact that it's rising or setting. I prefer just to move left, right, up, down. Other people say, yeah, I absolutely do need an equatorial mount, a so-called equatorial, because the axis is lined up with the Earth's, and one of the axes is lined up effectively with the Earth's equator. This talk is not about astrophotography. This is about how you go about choosing a telescope or thinking about a telescope. But given that this question inevitably comes in to everybody who says, I want to buy a telescope for somebody else, or I want to buy a telescope for myself, sooner or later they say, I want to be able to take pictures. And sometimes it's a question of expectation management in terms of, well, that's a whole different ballgame if you want a telescope to look through versus if you want a telescope in which you produce wonderful astrophotographs. So I'm not going to dwell too long, but just to fill you in on some of the background of astrophotography. It is possible to buy small cameras that will fit in any telescope, essentially any telescope, because eyepiece dimensions are effectively standardized. So you can always buy some cameras that will fit in any telescope, and they will probably work on bright objects. Bright meaning, in this context, the moon and a few of the planets, and you will be able to get images of those objects. But if you're interested not in the brightest things in the sky, but the faint so-called deep sky objects, if you're interested in photographing a distant nebula or a distant galaxy, then that's different. Then you will need long exposures. For bright objects, you can get away with very short exposures. But with the faint objects in the night sky, you will need long exposures. And remember that as the Earth turns, so the sky appears to rotate, you will need to follow that reasonably accurately if you want to expose for many seconds or many minutes or perhaps even longer. And so basically an equatorial mount then becomes not so much a luxury but an essential if you want to do long exposure astrophotography. People who are dead serious about astrophotography will either go out and buy themselves relatively expensive astro cameras, or they will try and use whatever camera they already have. For instance, I already have a digital SLR camera, so I prefer to use that because I've already got one, rather than go out and buy something new, as it were. And that's individual choice as to whether or not you want to buy yourself astro equipment for astro, or whether you want to say, well, I already do a bit of photography, I've already photographed the cat, I want to use that same camera on an astrophotography basis. And as I say, originally when I put this talk together, I was hoping that somebody else would then give a short talk on basically the pros and cons of different cameras. So that was there as a sort of caveat that this is not supposed to be detailed. It's just supposed to be you can do astrophotography with telescopes. But before I move off the subject, let me make one fairly important point. If you are interested in astrophotography, you do not need a telescope. That's something that some people sort of forget somewhere along the way. If you've already got a camera, preferably not just the one that's in your phone, but something perhaps a little bit bigger than that, a compact camera, a bridge camera, a digital SLR camera, a mirrorless camera. If you've already got a camera, then all you need to worry about is not, can I find a telescope big enough to put it on? All you need to ask yourself is, can I move it to stop the stars trailing if I take a long exposure? And that means putting it onto a motor in a box that will turn the camera at 1 revolution per day. That's what we mean by a star tracker. A star tracker is just a box that turns the camera at 1 revolution per day, and thus, if you set it down right on a tripod, as the sky moves, the tracker will allow the camera to follow. And using a camera on a tracker without a telescope, you can take pictures of nebula, you can take, here's the Rosette Nebula, you can take pictures of the Milky Way if you get away from light pollution, you get glorious sights of the Milky Way, you can take picture of nebula, supernova remnants, star clusters, etc. Not that many galaxies, because there aren't many galaxies that are bright enough to actually image without using a telescope, but that is still an option. So don't be fooled into thinking, I want to take interesting images with my camera, that means I must buy a telescope. No, there are alternatives, and star trackers are that alternative. If you want to do astrophotography with a telescope, it's fantastic and it's great fun, but it will take time, it will take effort, and it will take cash. And perhaps the last one is the limiting step for some people. Some people haven't got the patience. They hope to be able to do astrophotography within 5 minutes of setting up. That's not always possible. Some people really can't be bothered to put in lots of practice as to how to do this, because it's not something that you can just do instantly. And if you want a big enough telescope on a big enough mount and a nice enough camera, it can cost thousands of pounds. So just bear in mind, and just let's make sure that the expectation management is dealt with as to what it is you want and why it is you want it. So let's just briefly have a look at pros and cons of different telescopes. These are the basic telescope types: a refractor, a Newtonian. A Dobsonian is just the name of a Newtonian type telescope, but put onto a somewhat cheaper mount. And on the top left there we have Maxitov, and on the bottom left we have Schmidt-Cassegrain, what I mentioned earlier. So let's just dim those down a bit and have a think of the pros and cons of why you might choose one rather than the others. Refractors use lenses at the front end to focus the light, and I've already said that when light goes through glass, you tend to split the colors, or at least any attempt to bring all the colors to the same focus is problematic, and you have to spend a lot of money on a telescope to ensure that all the colors come to focus correctly, so that when you look at a bright object like Venus or the moon or something else, you don't see horrible color fringing around the edge where the colors haven't been brought to focus quite correctly. So you could argue that the refractors will always suffer from color fringing. It's just a question of how much. How much are you prepared to pay to get rid, or at least suppress and mitigate, that color fringing? Alternatively, you go for telescopes with mirrors that don't have the color fringing problem. So a Newtonian on perhaps an equatorial mount, or on a cheaper Dobsonian mount. And there I'm just reminding us that a Dobsonian is just a Newtonian telescope on the simplest mount that can be made. I've said before, and I'll say it again, these two on the left, based on the Cassegrain design, the Maxitov Cassegrain or the Schmidt Cassegrain, effectively have folded the light by reflecting off two sets of mirrors, the main mirror and a secondary mirror, and hence you get a nice long focal length in a relatively short tube. A long focal length means relatively high magnification. You might see more detail in the craters on the moon, or more detail in Jupiter or Saturn, etc. Large apertures, generally speaking, a very large aperture in a refractor is very expensive. Glass gets very expensive when the aperture gets large, whereas mirrors don't get ridiculously expensive if you're talking about apertures above 6 inches, 7, 8, 9, 10 inches. So large apertures, like the Newtonian and the Dobsonian here, and to some extent the Schmidt-Cassegrains as well, generally speaking, large apertures, meaning they're fairly good for faint objects. They're collecting a lot of light, so you can go for the fainter of objects. And you could argue that that is the best value for money in the sense that it gives you the largest aperture for a given amount of cash. So if you say, I really want the largest light bucket that I can afford in terms of collecting the light, I don't care about the bells and whistles, I just want to collect as much light as possible, that is the cheapest way of doing it. The optics of the three telescopes on the left, the Maksutov-Cassegrain, the Schmidt-Cassegrain, and the refractor, are sealed in the sense that they're not open at one end or the other, unlike a Newtonian, which is open at this end, and a Dobbo is the same. If it's open at one end, that means you can have things coming in, like water and damp and spiders and small furry objects that might happen to set up shop in your telescope. It's up to you, of course, to try and keep the telescope clean, but basically, because these systems are sealed, then it is still possible for damp to get in, but generally speaking, the optics inside generally need very little maintenance. And it might be that you need more for the exposed optics of the telescopes on the right there. Another factor which you have to take into account is just the ergonomics. Nothing to do with astronomy and the quality of the optics. It's just the fact that, well, how heavy is it and how easy it is to pick it up. So these telescopes here that are ringed are generally fairly portable, or at the very least transportable. This one down in the corner might not look very small and compact, but generally speaking, the tube comes out of the mount, and it's not necessarily something you want to go yomping over a mountain with, but it is something that you can probably throw in the back of your car and then go driving off to a dark sky site. Generally speaking, refractors and Maksutovs, relatively compact, nice, and easy to transport around. Let me give you an idea of prices. And I've printed a few copies of this out if anybody wants to sort of refer to it later. These are prices that I found by trawling as much information as I could find on the internet to get an idea of what you would expect to pay for various telescopes. These prices are now probably a year or two out of date, but the last time I checked, they seem to be still valid. So each strip here is a particular type of telescope: a refracting telescope, a Dobsonian, a Newtonian, Maksutov, and Schmidt-Cassegrain. I've got little arrows on the right because they don't stop at 700. They go on forever. You can pay anything you want to pay for a telescope. So this is only supposed to be the sorts of telescopes that you might consider to be your first or possibly your second telescope. And the sizes here indicate the aperture that you can expect to get for a given price for each of these telescopes. The manufacture cost of different telescopes are different, so you can't expect an aperture of 6" to be the same cost if you buy a refractor as if you buy a reflector, as if you buy a Maksutov, for instance. So what is a good starting telescope? What's a good telescope for beginners? I tried to read as many "these are the top 10 telescopes" as I could to see what people were suggesting on the internet or YouTube videos as the best telescope to buy. Bear in mind that we're talking about anything from £100 upwards. If you haven't got £100, don't think about buying a telescope. Binoculars are a much better bet if you're over on the left-hand side of this particular diagram. But if we assume that we're talking £100 plus, then what would be a reasonable investment? Well, it's like asking what's the best car to get. It depends entirely on your purpose and what you're buying that vehicle for. It's the same thing with a telescope. Some people have said, well, the best value is something around 200 quid. You can get a 5-inch. Apologies for the inches rather than millimeters, but I assume everybody is happy with that. It is still very common to talk about apertures of telescopes in inches rather than in centimeters or millimeters. So a lot of people have said, well, the best thing to start with is a couple of £100 will buy you a 5-inch Newtonian. It's certainly true that a 5-inch aperture will show you a lot of interesting objects in the night sky. Other surveys I've seen of which are the best telescopes to buy, others have said, no, don't buy a Newt directly on an equatorial mount. Get a Dobsonian on the cheapest possible mount, because then you can afford to get a slightly larger aperture. And why don't you go for a 6-inch or an 8-inch? Those will be wonderful. Well, yes, still within the restriction that if you're on an Altaz mount, you might find it difficult to follow objects as they're rising and moving through the sky and setting. But certainly you'll get a large aperture for a given price if you go for a Dobsonian. I would argue that anything in that blue box is probably worth having. In other words, you shouldn't fixate on, well, I should be thinking of this one rather than that one. As long as you go for something that is a reasonable quality and not something that is an absolute piece of plastic rubbish, I would argue that you could get a telescope anywhere in that blue box, and hopefully if you manage to use it on a few clear nights, you will get a lot out of it. You'll be able to see lots of interesting objects. When I looked at the Sky at Night magazine to see what they recommended, I was a little disappointed to find that they recommended an 8-inch Newtonian, fantastic telescope, but 700 quid, that's not what I call a starter telescope. It's not really a telescope for beginners. If you've got the cash, then that would be a fantastic instrument to get. But I think most people would start somewhere in that blue box. Let's remind ourselves as why we've got this elephant in the room down here. This purple is the Schmidt-Cassegrain. Notice that there's no such thing as a cheap Schmidt-Cassegrain. Although they are cheap in the scale of if they made them in a different way, they would be many, many thousands of pounds, it's still basically impossible to find a Schmidt-Cassegrain for a couple of hundred quid. These prices, of course, are new prices, not second-hand prices. And here you might not be able to read it. I put 6-inch OTA, which means OTA is the optical tube assembly. You can buy the telescope for that sort of price, £500, but that's not including the mount on which it needs to be placed, which will cost you more. If you want the 6-inch tube and a mount, then you're talking about the extreme end of this. So you could argue it's not really a starter telescope, but it's there just for reference. If you wanted an 8-inch or a 10-inch telescope, it would be way out here above £1,000. And for comparison and context, I've also included at the bottom, if you're interested in astrophotography, don't be fooled into thinking you have to buy something from the colored bars at the top there. If you're interested in astrophotography, you could use a star tracker. You can build yourself one. I can show you how. I've got some handouts here. You can build yourself a star tracker for 10 quid, 20 quid, 30 quid. If you've got the bits already, it might even be free. So you can certainly build one and use it to take images of the sky for next to nothing. If you wanted to, you can buy a clockwork version of a tracker where you just wind it up and then it turns the camera at the requisite speed. And a clockwork tracker would maybe cost £100. If you wish, you can buy motorized versions, and there's lots of them in that sort of ballpark there. If you want a very nice equatorial mount which is really sturdy and accurate enough to follow the objects in the sky, accurately enough for astrophotography, which is a very demanding requirement of a long focal length telescope, then you need a motorized equatorial mount which will cost a few hundred. And if you're the sort of person who would like one that's got a computer built into it, so you can say, take me to the Andromeda galaxy, and it will know where it is and it will point in the right direction. If you want it fully computerized, then you're probably talking about a mount which is of order £500. This is what I mean about astrophotography getting expensive. The best way of doing astrophotography is to spend hundreds of pounds on a mount and then think about what telescope am I going to put on that mount. And maybe you make sure the mount is really rock solid and is ideal for different telescopes, and you start with one telescope and then maybe you upgrade to another telescope and reuse the same mount. You don't have to stick with a particular combination of telescope and mount. But you can see that it doesn't take long before you're creeping to the right-hand edge of this graph if you're not careful. But remember, you can make a reasonable start for 100, 200, 300 pounds. Anything less than that, think about a tracker for astrophotography, or think about binoculars if you're interested in visual observing. Okay, just a few hints and tips and things to think about. You really can't go far wrong if you stick with the big, what are known as the big 5 manufacturers. There's nothing particularly special about those. They just have a large market share within the UK in terms of selling telescopes. Generally speaking, these 5 manufacturers produce quality stuff. So if you stick to these, you really can't go too far wrong. If you want to go out on a limb and buy from a different manufacturer, either you'll end up paying a lot, or there's always the danger you could end up with a turkey. So one thing to think about is maybe you ought to stick with something tried and trusted. When it comes to thinking about the aperture of the lens or mirror, remember the aperture determines how much light comes into the telescope, so that's how bright the image will appear. The focal length of the telescope will determine ultimately the magnification of the objects that you're looking at. But remember, magnification isn't the be-all and end-all of a telescope. So depending on what you buy, it might come with 1 or 2 eyepieces already with the telescope, and then you might want to think, after you've used it for a little while, do I want any different eyepieces which would give me different magnification, either a lower magnification or a higher magnification. But one thing to bear in mind is that is not the first thing you should be thinking about. Magnification is not as important as you might think it is, and it's far better to get the quality of the optics, the size of the front element, the lens or the mirror, and a nice sturdy mount to put it on. It's better to get that right and then deal with the concepts of different magnification with different eyepieces at a later date. But it is important to think about the ergonomics, as I mentioned earlier. Is this something that you're going to have to lug out of your house into your back garden? Is it something that's going to be permanently sited in your back garden? Is it something that you're going to have to take to a dark sky site because you've got too much light pollution where you live? Does it have to be portable or transportable, or does that not matter? These are all questions you need to think about for your particular circumstances. And as I've already said, just summarizing here, the criteria of what you need to think about if you're interested in visual astronomy is quite different than if you really want to go into the area of astrophotography. If you're interested in having a telescope that will simply move so that you can keep Saturn in the middle of the field of view while you watch it, or to keep the moon crater where you want it, that is a relatively undemanding requirement, and a lot of different mounts will do that. If you want to be able to take astrophotographs and track precisely the object, the distant galaxy, to make sure that you can take long exposure images, then the mount has to be more sturdy, more precise, and probably more expensive. So they are different requirements, so you have to be clear as to what it is you want to get out of your telescope, ideally before you let go of any cash. You might think it's a good idea to have a go-to telescope. I'm not absolutely convinced. A go-to telescope is one that's computerized so that you can ask the computer, show me the Rosetta Nebula or show me the Andromeda Galaxy. Personally, I think it's much more fun to find them yourself. There's always the danger that you don't learn your way around the sky. Maybe you don't want to, but if astronomy is a hobby, don't you want to learn your way around the night sky? With a go-to telescope, that will never happen because the telescope will do all the thinking and you'll just be looking at object 1, object 2, object 3, object 4. I think it's more fun to learn your way around the night sky and find these objects for yourself. Other people disagree. It's entirely your choice as to whether you go for a go-to telescope or not. They will be more expensive, so bear that in mind. If possible, try before you buy, rather than part company with perhaps hundreds of pounds of your cash. It would be nice if you can check these things out, for instance at an observing evening where you can look through other people's telescopes, ideally different types of telescopes, and then you can look at Saturn with this one, and you can look at Saturn with this one, and you can look at Saturn with that one, and you can say, well, that's the one for me because I was impressed by what I see, and it's nice and small, or light, or whatever, or it's a nice red color rather than a blue color. Whatever the criteria are, if you get the chance of looking through different telescopes, it's a lot easier for you to make your decision. It's like basically taking a test drive in a car before you decide to take the plunge. Sometimes you can get bargains second-hand, but be careful. It's always worth talking to other members of the society. If you find something that looks like it's a bargain on the internet, it might be, but it's much more likely to be a rip-off, so take advice before you send cash to anybody claiming to have a really nice telescope for a bargain price. Some random comments. Try to avoid the urge to add everything under the sun to your telescope. Some people buy telescopes and then think that looks rather naked, I want another telescope on the side, and then I want a guide scope, and then I want another telescope for wide field astrophotography, and it just escalates. Some people keep adding accessories until they run out of cables, basically. So it's not necessarily something you have to watch, because cash normally stops you from going completely overboard and adding everything under the sun to your particular system. But whenever you look, for instance, either in one of these catalogues, or more likely when you look at images on the internet, if you're scanning and Googling for different types of telescopes, bear in mind that images can be very deceptive. For instance, if you look at these two telescopes, perhaps you don't realize that they are not to the same scale. If you show them to the same scale, then they're obviously very, very different telescopes. And you have to ask yourself, well, what is a sensible observing height? Because if that's the telescope and that's you, how on earth are you going to use that? Are you going to put it on a table? Are you going to put it on a step ladder? Is it going to be a stable way of trying to point that telescope at a distant object? So it might be that you like the idea of a small telescope, but be absolutely clear what its size is. Don't be fooled by the fact that it looks quite nice when it's positioned next to another one. And of course, different sizes also means different weights. So generally speaking, large telescopes are often better than small telescopes simply because they collect more light, which is usually a good thing. But a big telescope is going to be heavy compared to a small telescope. And that might be a deal breaker. If you haven't got the wherewithal to lift 24 kilograms, even if it breaks down into two pieces of 12 kilograms each, if you can't lift that into the back of your car, it's never going to get used. Whereas something that's only a few kilograms, okay, the optical quality might not be the same. You might not be able to see as many faint objects. But if it's only 2 kilograms, are you more likely to use it compared to a Leviathan like this on the right-hand side? So think about the ergonomics as well as the astronomical quality of the optics. Read the specification. Make sure you know what telescope you're buying if you're about to take the plunge. This is the telescope for me. This is definitely the one I want. Make sure you've read the specs so you know what you're getting. Because that is a superb telescope. But do you actually realize how big it is? And we see from the... yes, it is actually 300 kilograms. So that doesn't take 2 people to lift it. That takes a little team of Sherpas to lift it. So, yeah, you're not going to buy that by accident. That's obviously a little bit tongue-in-cheek there. And yes, that is extremely heavy. But Mead know that, and they try to mitigate that by making sure that if you do buy one, then your bank balance is going to be an awful lot lighter. So that's fine. So let me just summarize. Your options, as you can see simply by flicking through a catalogue with thousands of telescopes, your options are many and varied, and that's good. But it's also bad, and it's also very confusing if you're new to this and you really don't know where to start. Try not to suffer from analysis paralysis. If you try and work out which is the best value for money for 1,000 different telescopes, you'll spend all your time analyzing the telescopes on a spreadsheet and never actually do anything. So look at what you can afford. Take advice from other people in the room. Make a decision and enjoy your stargazing. Make full use, of course, of the resources of your astronomical society. And the most valuable resource of a society is probably the people sitting next to you, the members. Okay, there's lots of experienced people. They will be able to give you very sensible advice. So what is the best telescope to get? Some people would say there is no such thing as the best telescope. Other people disagree. They say absolutely, the best telescope is the one you actually use. Okay, I hope that half-hour talk has given you an idea of what to think about in my rough guide to buying a telescope. Thank you.